We're given a circle which contains three straight lines joined together at right angles of lengths 5 centimetres, 6 centimetres and 4 centimetres, which are touching the circumference of the circle at three separate points. We're asked to find the radius of this circle. I've seen a few different ways to solve this problem. The method I'm going to use is just going to use basic GCSE high school maths with some Pythagoras' theorem, some circle theorems, but anything that a GCSE high school student should be able to use. So to start this, I'm going to extend that 6 centimetre line out until it reaches the circumference of the circle, and I'm going to label this length as y. Now if we were to join the end of y to the bottom of 5 like this, we can see that we've got a right angled triangle. But as this is a right angled triangle where all three corners are on the circumference of the circle, by our circle theorems, this means that the bottom right hand side, the hypotenuse, must be a diameter of the circle. So we can label that r for that radius, r for that radius there. So we've now got a right angled triangle, we've got all our lengths labelled. We can use Pythagoras' theorem. So the square of the hypotenuse is equal to the sum of the squares of the other two sides. So 2r all squared is equal to 5 squared plus the square of 6 plus y. Expanding that, we get that 4r squared is equal to 25 plus the expansion of those brackets, so 36 plus 12y plus y squared. Bringing the 25 and the 36 together, we get 4r squared equals 61 plus 12y plus y squared. I'm going to call this equation 1 because we're going to come back to it later. So far so good. We've got an equation, but it's got two unknowns, so we're going to need to find at least one more equation to be able to solve this. So let's create some more triangles on our diagram. If we join our top point to the right there, we've created another right angle triangle with a height of 4 centimetres and a base of y. So if I label the hypotenuse z, Pythagoras' theorem tells us that z squared must equal 4 squared plus y squared. Now we've introduced a third unknown here, so we still need to find some more equations. And I'm going to do this by creating another line on the top left there, which we're going to label m. Now this is going to be another right angle triangle because again, we've got three corners on the circumference. The base is the diameter. So our circle theorems tell us that we must have a right angle at the top there. So we should be able to do this to find z. Furthermore, we can find m quite quickly. If I just add another triangle in here, we can see that m is the same height as the 5 and the 4 that are on our diagram to start with. It's the same width as the 6 that was there to start with. So by Pythagoras' theorem, m squared must equal 4 plus 5 all squared plus 6 squared, which equals 117. So putting these together for our m, z and r triangle, we can see that 2r all squared, that's our hypotenuse, must equal m squared plus z squared. We know m squared and z squared now, so 4r squared is equal to 117 for m squared plus 4 squared plus y squared for the z squared, which will simplify to 4r squared equals 133 plus y squared. We're going to call this equation equation 2. Right, we're almost there now. We've got two equations, 1 and 2. They've both got two unknowns, r and y, so we should be able to bring these together to solve it. Now what I notice here is that both of these equations have got 4r squared on the left hand side, so we can bring the right hand sides together and set them equal to each other. So 61 plus 12y plus y squared from equation 1 is equal to 133 plus y squared from equation 2. Then subtracting 61 and y squared from both sides, we get that 12y is equal to 72, hence y is equal to 6. We can now put this into either equation 1 or 2. I'm going to put it into equation 2 just because it's smaller. So 4r squared is equal to 133 plus 6 squared. There's our y value. So that's 169. So r squared is equal to 169 over 4. As r is a length, it must be equal to the positive square root of this. So r is equal to 13 over 2, which is 6.5 centimetres. If you've enjoyed this video, don't forget to subscribe to the Doing Maths channel or check out some more of my videos by clicking on the links here.